Hey everyone, today we're going to talk about score boosting and vector retrieval. Score boosting is a re-ranking step that's applied after your initial vector similarity search that boosts the relevance of certain vectors based off of context or business logic, based off of certain conditions that you want to apply. You can actually build very sophisticated expressions to build out different relevance logic and boost the relevance for certain vectors. Now, 𝗀𝗔 𝗀𝗂𝗕 recently wrote a blog article on this. I'm going to put that blog in the video description for you to check out. And what she was looking at was specifically the decay functions in the score boosting, and that's going to be covered in this video as well. She had found that in our Discord community, many people were looking for some guidance around decay functions. So today, I'm going to start with just the basics of score boosting, and then I'm going to go into how decay functions work and how you can use that for your relevance and irrelevance drop-offs. So let's go ahead and get started. So first, why boost scores at all? Well, vector search alone doesn't actually prioritize or weight any of your search results. It actually returns them all with equal weight. Now, that is using approximate nearest neighbor search, but you might want to boost the actual vectors that are more contextually relevant or that have the business logic that you need to be more relevant to your application. And so using Qdrant score boosting allows you to get this second step in the retrieval where you can actually get better results for your application. So some other examples of this are where you might actually use this for documentation search. We dog food this ourselves at Qdrant. You can go to our documentation where we have our own Qdrant search engine used for the documentation search, and that is a hierarchical weighting where it prioritizes the title, then the content, and then the code snippets. Another example of this might be a geolocation search. So based off of the nearby restaurants, you might get better recommendations. Maybe restaurants that are far away are going to score lower in your recommendations. And there's another type of way this might be used, which is freshness. So time search, where the most recent vectors are going to be, or metadata or payload field are going to be surfaced with a higher scoring. So this might be news articles that are more recent than older articles. Those will surface higher and better in your information retrieval. So this is how it works in a step-by-step. First, you're going to actually fetch the initial results with a prefetch. Then you're going to apply a formula query, and that's going to re-rank it. And then lastly, you're going to combine that base score with the weighted payload conditions. Now, these weighted payload conditions, they can be included in the formula syntax, which includes sum, multiplication, division. It also includes score references for making other types of sophisticated expressions. You can include field conditions, and you can include math and geo functions. So you actually can do quite a lot with the score boosting functionality in Qdrant, and that allows you to, again, build sophisticated business logic and business rules. So with our example with document search, where titles are the most important, then content is important, and snippets are the least important, this is a little bit of what the pseudocode looks like. You take your score, and then that is equal to the base score plus the title. If it's a title, then multiply by 0.5. If it's content, multiply by 0.25. So that's a little bit of what that looks like. But in actual Python code in Qdrant, this is what that looks like. So you have the client, you have the query points, you have the collection name is documentation or docs, you have your prefetch, then you have your sum expression here with your score multiplied by 0.5 when it matches any of header 1 or header 2, or then when this is multiplied by 0.25, that's for when it matches a paragraph or a list item tag. So that is how the documentation search can work, but you also have a geo search, and the way this looks like is you have this idea that you're going to take each point with a geolocation. You're going to use something like a Gaussian decay to favor closer points, and then from there you're going to actually get good recommendations, and this is great for local search. So the pseudocode looks like this. You have your score is equal to your base score plus your Gaussian decay of your distance. So what the decay functions are actually all about, let's talk a little bit about understanding them. So the decay functions map numeric payloads into relevance weight, going from 0 as the most irrelevant to 1 as the most relevant. And so some examples of this are the linear decay function, which takes a steady and constant decrease into 0. This can be for straightforward price decreases or other relevance that might be decreasing linearly. Gaussian is smooth and symmetric, but it's going to asymptotically approach 0. Now, this is your normal curve or your bell curve, and this is a good balance curve. So this might be an acceptable range around the video length. So maybe 9 minutes is the most you want to watch for a video, and 4 minutes is the least you want to watch. You want something that's between 4 and 9 minutes. Maybe you pick a target that's between there, and you use a nice balanced Gaussian curve and Gaussian decay around that. An exponential is a rapid decay. So this is rapid decay initially, and then it flattens out. So maybe freshness, like where older items lose their relevance more quickly. So let's take a look at how these decay functions work in an interactive tutorial. So first, let's take a look at this simple linear decay. You can see that this green line goes from an ideal value, the target, which is 1, and the ideal value of the score is 1, but the target itself is 0. So you can see that over here. And so this is if we want our input value to be 0, then our score boosting would be at 1. And this decreases linearly all the way to 0, and you can see this curve. Now, there is a midpoint here as well, where the midpoint is the relevance, but the midpoint is the relevance at the target plus a scale value. So the scale and midpoint control how quickly the relevance drops from the ideal. So for instance, if I turn on scale, you can see that you can change how fast or quickly, how fast or slowly the relevance will drop. So we'll set the scale at 5 just to keep it nice and simple. Scale at 5. And then the midpoint, you can see that also has an effect on how quickly the values will approach 0. So you can kind of adjust the area under the curve this way as well. So that's the midpoint value, and we'll keep this at 0.5. And the target, like I talked about, was the input value. This can be anywhere from any value you'd like on a continuous x-axis. So it doesn't actually have to be at 0. For instance, if you're trying to look at something like size or weight, you might have a positive value that's like maybe 10 pounds or something that's like 30 pounds. So your size might actually put this in your positive axis. So that's how the target works. So we'll take the target down to 0 just to make this nice and clean. And let's look at some of the other functions. So there's also the Gaussian decay, and you're seeing this in purple. So now the Gaussian decay is a way to look at a normally distributed bell curve that has a more balanced decay down to irrelevance from the ideal target state. And you also have an exponential decay that is this red line that is much more aggressive. So if we take a look now at the target will just shift it just back and forth. Okay, that's what we expected to see. But let's take a look at the scale. What does that do? Well, that gets really interesting. You can do a lot there with that scale variable and that scale parameter in your actual score boosting. And then same thing with the midpoint. You can choose something with your midpoint as well and change the shape of your decay function. So here's a code example of what that video length would look like with Gaussian decay. So here you see the prefetch, you see the formula, you're using sum of score with Gaussian decay, x is your duration, and then you have your target at 5, your scale at 4, and your midpoint at 0.5. An example of this decay, of these type of decays with the exponential decay, and this is used for freshness, you're seeing the same type of thing, but here we're using exponential decay. We're using a date time value as the target, and the scale is 86,400, and the midpoint is 0.1. So some tips and caveats for this. First of all, you must know sensible ranges for X, target, scale, and midpoint in advance. These can't be dynamically calculated or determined at query time, so you want to play with it and find what works best for you. And the best way to do this, or one of the ways I like to do this, is through that interactive app that I just showed. So I'm going to put a link to that in the video description so you can actually play with the decay curves and see what's working best for you. And then you want to actually play with the results itself, and you only want to use these decay functions when there's like an intuitive business logic or context that you want to implement in your numeric feature relevance. Now you can try all this for free on Qdrant Cloud. It's 1 GB, free forever, just enough to play with some basic functions and see if you're liking this and you're getting better results. These features were introduced in Qdrant 1.14. Qdrant Cloud is currently on 1.15 and is always kept up to date, so you will always be able to try these if you try these on Qdrant Cloud, or you can do a Docker pull and use the open source Qdrant locally. So that's a great way to get started and try this out. So I'm going to put a link to the documentation for these features in the video description. I'm also going to put a link to Jenny's great blog in there, and that's an awesome way to learn about the decay functions and how they work and some use cases. So that will be in the video description. And if you have any questions, I recommend going to our Discord community. There's thousands of great experts and people helping each other on there. We're monitoring very closely, so you can ask your questions there. Our CTO's on it all the time, so you'll even see him on there. Otherwise, you can ask your questions in the video comments, and we'll do our best to get to them. And other than that, good luck and enjoy your vector search. Let us know if you have any questions, and have a good one. Thank you.